Welcome to History of Physics. Today we explore Wolfgang Pauli, one of the founders of quantum mechanics. Born in Vienna in 1900, Pauli grew up in a culturally mixed family. His father was a chemist from a Jewish family and his mother was Catholic. His godfather was the famous physicist Ernst Mach. By age 18, Pauli had already written a paper on Einstein's general theory of relativity and he earned his doctorate in Munich in 1921. Pauli's career took him to leading centers of research. He worked with Max Born in Göttingen and with Niels Bohr in Copenhagen, and at the University of Hamburg he developed what became known as the Pauli exclusion principle. This principle states that no two identical fermions, such as electrons, can occupy the same quantum state. It explains the structure of atoms and the stability of matter and is the reason the periodic table has its familiar form. Pauli also introduced the concept of particle spin, showing that electrons behave like tiny magnets. To save energy conservation in beta decay, he proposed a neutral, almost massless particle later named the neutrino. This mysterious particle was finally detected decades later. For these insights, Pauli received the 1945 Nobel Prize in Physics. In his personal life, Pauli faced tragedy. In 1930, his mother died and his marriage collapsed. He sought help from the psychologist Carl Jung, who analyzed Pauli's vivid dreams and corresponded with him about the connections between physics and psychology. Pauli critiqued Jung's theories and helped clarify the idea of synchronicity, meaningful coincidences that are not linked by cause and effect. Their exchange is recorded in the book Atom and Archetype. Pauli spent the war years in the United States and later returned to Zurich. He was fascinated by fundamental constants, particularly the fine structure constant, whose approximate value 1/137 haunted him. In 1958 he was hospitalized in room 137 of a Zurich hospital, where he died at the age of 58. Pauli's exclusion principle, his prediction of the neutrino and his interdisciplinary dialogue with Jung continue to influence physics and philosophy, reminding us that understanding reality requires both rigorous mathematics and an openness to deeper patterns.